Welcome to the Science Program. My name's Jeff. Welcome to the very first show, a show all about science, cool topics, and trying to get a handle on something beyond the topic of the day. We've all seen those inspirational shows where folks kind of jump in and give you some great advice, and you're left thinking, wow, that was fantastic. What do I do with it? What's the next step? Well, this is going to attempt to answer a lot of that. And the idea basically is if you've seen like the TED Talks or really any kind of interesting snippet on the internet, and you think, okay, well, what's next? Or what do we do with the information? This show attempts to take that topic, have a good conversation about it with folks that know what they're talking about. Myself, I don't really know what I'm talking about, but I like to ask interesting, intriguing questions. And those experts then contribute the topics to some kind of scientific data. So the idea is we assemble some data after the conversation that can then be followed up on and dealt with and understood. And beyond the program itself, beyond the actual session that we record, we want the conversation to continue. So there'll be a page that will be on thescienceprogram.com where folks can go and continue to keep up with the topic that was discussed, looking at all what I call the key science indicators. And other experts hopefully will chime in, additional shows will follow, and the conversation hopefully continues from there. Very much a hobby. You can see the elaborate studio behind me. My goodness. And the only guy that I would, I think, really trust with trying this experiment with me, my former advisor, by the way, my name is Jeff Blazinski. Did I say that? My former advisor from Penn State. Please welcome my guest, the very first guest of the science program, Brian Dempsey. Brian, thanks for joining me.
Jeff, I'm really happy to be here.
Fantastic. I got to fix my screen source here. Highly professional thing that we're doing here. Man, is it great.
Yeah, I have really bad lighting here. I'm sorry.
You can see. Now, here we go. Can I try this? There he is. All right. Welcome, Brian. Brian and I have been talking about this for about, I don't know, the past, it's been a year, I'm afraid to say.
Probably.
I'm really afraid to say it's been a full year. So I got you on the split screen here. You can't see any of this. I got Brian here on another computer. And by the way, any good show, and this is the thing, I forgot to mention this to you, Brian. Any good show that you watch, a lot of sports shows out there. No surprise, I'm not very into sports much at all. I don't really prefer sports, but I do like sports radio shows that you see on TV. Nice microphone, some headphones. So that's the idea. This is like the sports talk show for science folks.
Okay,
that's the idea. We're doing it. So, Brian, thanks for joining us. We're going to jump right into it. The main topic for the first show on the science program, fracking. An interesting topic. There's a lot of discussion, a lot of emotional discussion out there. From a science perspective, though, kind of some opportunity for us to get a better handle on the data, wouldn't you say, Brian?
Well, yeah, there's, you're right. This is a totally emotional subject, and also, it's anytime you're dealing with an energy issue like this, people come down on either side. So I like what you're doing, trying to find some indicators, and we can identify what those are and then invite people to participate.
Absolutely. And again, extremely informal. You can see the production quality here. The cool thing about it, kind of an underground feel. Not quite sure what I'm doing, right? I mean, we should probably tell everyone that you're teaching this particular program. Just so happened that when I reached out to you about this, that you were teaching this and already talking about it. So the material is very well developed. Obviously, your background at Penn State lends itself to offering a lot of credibility around this topic. So
well, truth in lending here. I've been retired a couple of years, as you know, Jeff, and so I've been teaching this class. I taught this kind of stuff when I was at Penn State, but I've been teaching this class to retired folks as well. I've had a lot of opportunities to go out and talk about Marcellus Shale, and this is kind of the general material that I present.
I think that's the best audience, though, because that's an audience that wants to be there. You want to be there, right? So, I mean, the topic of the day is really something that's drawing people to learn about it and for you to develop the materials and talk about it. So this is exactly what it's all about. And by the way, future shows, the idea being that there's topics about maybe food safety, economics, poverty. I mean, you pick the subject that's polarizing or challenging that politics or other things don't really offer a good way to fix. The idea behind this show is that we provide that context and that perspective so that the The discussion's positive and it's data focused. So you ready to jump into the material?
Yeah, let's do that. Do you have that up on the screen?
Yeah, let me see here. I got to do this here and click this and this one. All right. And Brian, I'm going to start you off on, let me get back to my source here. We're on the very first slide, Brian.
All right, so that's the title slide, right?
Yep.
That you're looking at there. So there's just a bunch of pictures on there that identify some of the things that are important about Marcellus Shale. So in the upper left, that is the Marcellus Shale, kind of weathered. If it were down to the ground, it'd be a lot blacker than that. It has a huge amount of organic matter. And of course, one of the bad things that people note about Marcellus Shale is the big disruption, all those trucks that are coming into some of these rural areas. So the picture on the upper right is one of the drilling sites. All the water that has to be pumped in, all the water that has to be taken away, all the chemicals that have to come in there for the drilling. And the only other one that I'll mention on this slide, Jeff, is that one of the bottom center shows a drilling, sort of a idealized drilling activity, with a whole bunch of different diameter pipes going down there. Those are supposed to be the different casing wells that are different casings for the different wells that are going down. So each drilled well has these days has a whole bunch of casings going down to protect the groundwater that they're drilling through, and also to protect the well itself as they're conducting that gas back to the surface. So that's an issue that's kind of important, because if they don't case, then there's a great possibility for having some contamination.
Right.
So let's just hop to the second slide then, if you don't mind.
Yep, that sounds good.
All right, so just some basic information for people who might not know a lot about shale and what it is. It's a sedimentary rock. In other words, it was deposited a long time ago. These are materials that went into the oceans, into the lakes, and they fell to the bottom. And these shales are clays, really, initially. And they had a huge amount of organic material associated with them. Clays can absorb organic materials, and so when they were deposited and then compressed and with great pressure and temperature, that turned into stone, all that deposited clay. So that's what a shale is. It's really just clay that has been turned into a stone. And they're black. The Marcellus shale and these other shales that they're starting to frack are black because they've got all kinds of organic carbon in them. There could be some other reasons for them being black, but it indicates that organic carbon was deposited under conditions such that there was not enough oxygen to get rid of it all for microorganisms to decompose it and turn it into carbon dioxide. So it stayed down there.
And how does that differ from just good old-fashioned coal?
Well, so there are, we can have different kinds of fossil fuels. We can have gas, we can have oils, we can have coal. And of course, we have different grades of each one of those things. And in large part, it depends upon, and I'm not a geologist, I better make that clear from the very start. I'm an environmental chemist who worked in Department of Civil and Environmental Engineering when I was at Penn State. But from my perspective, then these were deposited under different environments. Some were deposited under saltwater conditions, some were deposited under freshwater conditions, and so a coal is a material that is in the process of being converted from that natural organic matter into something else, but it's still in solid form. And on the other hand, when we go to gas, then you see that third point on there, that methane, which is CH4, is produced when the organic matter has been down there for a long time, and it what I would call disproportionates. In other words, part of it gets more reduced. That's the methane that we want to mine and burn, and part of it gets more oxidized. That's the CO2. So it's the methane that stays down there, and so that's so we have all of these fossil fuels. The methane, this particular methane in the Marcellus Shale, was deposited under very saline conditions, extremely, as a matter of fact, those deposits are what the geologists would call hypersaline, extremely high concentrations of salt. But because there was so much organic matter down there, there's a huge amount of methane. So the Marcellus Shale, is a lot of times identified as the second largest deposit of methane in the world. It's pretty amazing.
Wow.
It's right here.
Just in Pennsylvania.
Yeah, well, the Marcellus Shale extends over several states, but it's likely that Pennsylvania is the richest of the states in terms of how much methane is in the Marcellus Shale underneath our state.
Wow, that is fascinating. My goodness.
Yeah, I think there's another slide coming up that shows some of that.
Yep.
So
I'm on the third slide now.
Okay. All right. So Yeah, so there you go. I mean, that slide shows the sort of the map of Pennsylvania. You can see it outlined there. If you know that that Lake Erie is on the upper left there, and so that little prong of Pennsylvania that goes up there is Erie, and so you can see in this map that this particular part of the Marcellus Shale extends into New York. It goes through a lot of Pennsylvania, goes down into West Virginia, and it also extends over into Ohio.
And this is where traditional natural gas has been taken for years, right?
Well, no, as a matter of fact, the this stuff is down in shale. So shale is clay. It was formed into a rock,
Okay.
and so clay is very fine grained. It's not very porous, and also the Marcellus Shale is way down there. It's like, typically in Pennsylvania, 5,000, 9,000 feet down. So they had to develop some new technologies in order to extract this, and so we've been mining methane, natural gas, in Pennsylvania for a long, long time. Some of the first oil wells were here. Some of the first gas wells were in Pennsylvania. But those are much shallower.
So, like the older natural gas, then, was that mined completely from different formations other than the Marcellus Shale, right?
Correct.
Okay. I did not know that. Yeah, because I thought like through the 70s and 80s, I mean, it was.
Oh no! I mean, you go out in the woods in Pennsylvania, you see a lot of what they call conventional wells. These are wells that are just vertical, whereas the Marcellus Shale, most of the time now, they'll drill down and they'll then drill horizontally following that seam.
Right.
So they have to have that great technology in order to be able to follow that seam. The seam might only be 50 feet thick.
Okay.
And it's over a mile down there. It's pretty incredible, as a matter of fact, that they're able to do that. And then they have to have these fracking technologies also to open up the pores in the rock so that the gas can escape.
And that's totally different than traditional natural gas.
So a lot of times they'll differentiate between these things by calling the older gas that's still being mined in Pennsylvania conventional gas, and then the fracked gas and some other kinds of gas that they're getting at in oil is called unconventional.
Okay.
But so one of the things on this slide, you see that stuff was deposited 380 million years ago to 400 million years ago, and so it's had a long time to be down there for that organic matter to be turned into gas, and it's been trapped down there because of the tight pore structure and overlying beds that are also not porous.
And I'm curious, who discovered a technique to get that? Was it like, do you remember a phase where someone published a paper and said, "Hey, this seems like a good idea. Let's try and go after this"?
Yeah, actually, I wish I could remember the names of the guys, but and I don't think it was an academic. I think it was somebody who was using technologies and thought it might work, and I believe they went up into the Bakken oil field in North Dakota, where they're using fracking techniques up there mostly for oil rather than for gas, and just decided they thought it would work. Part of the thing, of course, is that it costs. Not only do you need the technology, but it costs more money to get this out of the ground.
Right. And
that's the way things are going for all of our fossil fuels generally. It costs more to get the stuff up that was not as if it was easy to get up, they probably got it already.
And when did fracking then really pick up steam and start to take hold?
Well, there were a few gas fields that were fracked before the Marcellus, the Barnett, for example, in Texas, and so that would have been probably the early 2000s, maybe the very end. They've been trying to do this for a while, for maybe a couple of decades now, but it's really only taken off in Pennsylvania since about 2007.
Wow, so extremely new.
Mm-hmm.
Wow. Okay, yeah. So let's keep going through the materials.
All right.
So I will find.
All right, so this is a slide that describes why it is that they can do this. You see, and there's lots of videos. I have a hot link there to a place with Console Energy. They have a pretty nice video that describes how that drilling occurs and all the casing that they have to do and everything else. But they've figured out how to do this directional drilling because they have to go down, as I said before, over a mile in most cases. Then they got to turn the drilling so that they're going horizontal, or at least they're following the bed, which might not be perfectly horizontal. So they have to have information about where that bed is, and that bed might only be 50 feet thick, might be a little bit more than that, might be a little bit less than that. And so they have the technology to do that. The fracking itself, the hydraulic fracturing, what they do is they have to basically shoot bullets into the formation. They isolate a section of that horizontal drilling. They shoot bullets into the formation to open up fairly large holes. And then they, at very high pressure, they inject some chemicals that assist in the transport of sand grains and also open up the smaller pores. And so the sand grains are the proppants. Water is usually used as the solvent to get all these things down there. And then they have to have things to make sure the surface tension is okay, to kill microorganisms, because they don't want microbial growth, to avoid scaling, to do all of these other things. And so that directional drilling and the ability to do that fracking, those are the two main things that they've been able to do. A couple of other things that are kind of cool is that most of the time when you go out in the field and see these sites, or you hear about them, they might have 12 wells that are drilled from a single pad. So this is a big benefit in a sense. There's only one pad, and each one of these wells is going a couple kilometers horizontally, up to a couple kilometers horizontally under the ground, and they might have 12 of these things. So they can cover a huge area from that one drill pad. But that's one of the reasons why there's so much activity at that one site, as you see from all of those trucks.
That's unbelievable. And I've wondered, so when people sign away the mineral rights, it obviously has to encompass the radius that they're drilling, right?
Well, that's actually, that's one of the contentious issues, about whether somebody who does not want their land to sell the mineral rights to their land, whether they can hold out or not,
right. And, like if you're under their land, like there's got to be some stipulation that says you can't cross that vertical plane, right?
Yeah, or you're not supposed to extract the gas from that property, as far as I can. That's my understanding of that law, and so that can cause some controversy among neighbors, as much as between the gas companies and the people who are selling mineral rights or own the property, the mineral rights.
Absolutely.
Yeah. Another thing that can happen sometimes. So these issues are called pooling. Another issue that can happen is, it could be that several different companies bought the mineral rights, and should they be allowed then to share those mineral rights so there can just be one pad that covers a huge area, and in general they are allowed to do that. So those are legal issues and social issues that are very important.
Absolutely.
So then other issues that they've been dealing with and that have assisted in this is that they have these mobile rigs, because if you can drill 12 wells from one pad, and then you have rigs that are mobile, both in that local vicinity and also be able to take them to another location, of course, that makes the whole process a lot cheaper and a lot easier. And another thing that we'll end up talking about a little bit is this whole business about what do you do with the frack water that comes back. Now, The conventional wells have always had production water. They've always had frack water and production, well, not frack water, but they've had production water coming back because there's water down in the ground. And when you mine the gas, it comes up with it. And so what they have to give you the punchline a little bit early here, one of the things that Pennsylvania has been fairly successful with is reusing that flowback water and shooting it back down for more hydrofracking. It's a relatively dry formation, so a lot of that water stays down. Does that make sense?
No, yeah, it does. Well, yeah, I guess we'll get into that because I don't want this whole idea that we would have some ability to measure some of these key issues like mineral rights, right? I mean, it's easy enough to say, okay, you sign away your mineral rights, but what are the implications? What are some of the data points that define signing away your mineral rights?
Yeah, and it's very important that people be educated about what they do when they sell their mineral rights. How much should they get? And should they get all that money at once? Are they going to get some royalties on the gas that's being mined? All of these things happen, of course.
Right.
Or what's going to happen? How are they going to protect themselves against possible contamination of their wells? All of these things. So you can see how complicated this thing is, Jeff. I mean, it doesn't take just one person like me to figure out all this stuff. I'm trying to be a generalist on this, but obviously I don't know the answers to all of these things.
Well, and the things that are curious to me too, and I mean, obviously, hopefully there'll be more discussion and more done after this particular program. But the idea is that I didn't know until just now how new it is, because a lot of the ads and things that are on TV, radio, you'll hear about, oh, we've been fracking for years. And until 5 minutes ago, I thought, oh, natural gas. In other words, this is a little different trick, but turns out it's completely different, completely new. And,
well, they have been fracking for years, but it's not, they haven't been doing a lot of fracking for 2 decades, for example.
Right.
It is new. Yeah.
Right.
And as I said before, in Pennsylvania, it's even newer. And every place they go, I think that they have to they have to deal with the local conditions, the local geology.
Right. So you ready for the next slide?
Yeah, let's do the next one. So there's this is real quick. If you look over on the right-hand side of that diagram, and that one that I have a red box around, that's the Marcellus Shale. And so this shows the technically recoverable resources in terms of the total amount of energy that's available. And the only one that is bigger than Marcellus Shale, according to these estimates, is the fields in Iran, Qatar and Iran.
Oh, wow.
Which is quite a bit larger. But the Marcellus Shale is considerably larger, about twice as large as the Haynesville, which is in the United States, or another formation in Russia, and so on. So it is pretty incredible that we have such a huge reservoir of gas under Pennsylvania, Ohio, New York, West Virginia.
That is stunning. And then looking even just some of the other countries that are listed on that chart. I mean, obviously the U.S. shows up a few times, but there's Russia. Russia's a few times in there. But yeah, that one particular formation, I mean, it's twice as much as the next one in line, that Haynesville Shale in the U.S. Right. Yeah, just unbelievable.
Yeah, that is. And at Barnett, where I told you that they accumulate a lot of information about fracking, that's the third one from the left over there. It's much smaller than the Marcellus, but they got a lot of information about how to accomplish this, and of course they generated some problems there too, just like with the Marcellus, maybe more than with the Marcellus. The other thing about this slide, Jeff, is so the green is what's called unconventional, so that's mostly fracking.
Oh, okay.
And the blue is conventional. So you see that there have been some other places where fracking has occurred, and I already mentioned the Barnett. The Haynesville is in Arkansas. I'm sorry, the Fayetteville is in Arkansas. And so they have been doing this some other places.
And is it safe to say that conventional is also much better understood?
Well,
or is that a loaded? Am I reading too much into it? Like when I see conventional, I think we know what we're dealing with in terms of the mechanisms, the real costs, whether those are environmental or fiscal.
No, I would question that statement. You remember the Deep Horizon from a couple of years ago?
Oh yeah, okay, there you go.
Okay,
yeah, it kind of ruins it. Right. Okay. So that makes sense. So you ready to go to the next slide?
Yeah. Let's go. Let's do the next one then.
Okay.
So this was my attempt to sort of cover a lot of bases here about some of the things that might be good about Marcellus natural gas. So when I've given this talk to these retired folks here in the OLLI program, I've called it the Marcellus Shale, the good, the bad, and the ugly. And there's plenty of things that fit in each one of those categories.
Right.
So if you look at those blue boxes over there, here's the things that I think couldn't be used. They're not totally agreed upon, and I wouldn't necessarily be strongly in favor of all of these conclusions, but these are things that people say. So they say it's cheap. It's not as cheap as coal, but you see over there with natural gas that it's cheaper per million BTUs than petroleum, and retail electricity is a lot more than that. It's relatively clean. Okay, now there's a lot of contention about that. How clean is the natural gas?
Right.
It certainly when you burn it, it's a lot cleaner than coal, because you don't have the particulate material. Natural gas is mostly CH4. You burn it, it turns into carbon dioxide and water. Whereas when you burn coal, you got mercury. You produce sulfur oxides and nitrogen oxides.
Oh, so it's interesting. So the need for scrubbers and things, you don't really need that with natural gas then, obviously, right? Because you're burning
There's no
it.
Sulfur.
You burn it right in your home. Yeah.
Yeah.
Okay.
People say it's pretty compatible with renewable energy. Now, I've had somebody disagree with this statement, in these OLLI classes, that that gas-fired electricity plants can power up pretty fast, and so like if you have solar, you have wind, you're only going to have energy from those renewable energy sources when the sun is shining or when the wind is blowing, and that can cut off pretty soon. So you'd like to have something so that you can quickly generate power to feed the grid when the sun's not shining and the wind's not blowing.
Right.
And it seems that gas is much more successful than coal for doing that.
Coal, there's a longer cycle to start up, right?
Right. Yeah. It's more difficult to heat up, cool down, change the amount of power that's coming out of that facility.
Interesting. Yeah. So literally with gas, you can dial it up and down as you need it.
It's extracted in the USA, so something like 90% or more than 90% now of the natural gas that we burn in the United States comes from the United States. As a matter of fact, they were talking about the possibility of constructing liquefied natural gas ports so they could import natural gas into the United States. But now, with all this fracking, they're turning that around. They're thinking about exporting, which is another socioeconomic issue, whether we should sell our stuff. Of course, we got plenty of coal in the United States, and we're doing better on oil than we used to, in large part, because of the unconventional extraction of oil. But with natural gas, we have as much as we need in the United States right now.
Interesting.
Easy to transport because it's the gas. You can put it into a pipeline close to the Northeast market, where there's a great demand for this, so that helps. And then there's controversy about this as well, but in general, people feel like it generates jobs.
And I do like the whole premise of your the series that you've been teaching about, because as we've talked before, there's positives, there's negatives, there's kind of neutral observations, right? I mean, it was fascinating that we happened to talk, a year or so ago about this, because this is exactly at the heart of what we're dealing with in terms of the politics and the policies. Is that yes, there are good things. I mean, it's easy to say. You can see right here on the slide. There's some great things, but you have to put that in context. And I'm curious too about the dollars per million BTU. Is that factoring in other costs? In other words,
no.
Right.
People always talk about external costs. Well, it factors in some costs.
In other words, the cost of petroleum, natural gas, biomass. There's a whole supply chain that goes on to produce those gases, and I'm just curious, at the end of the day, what those numbers look like. You know what I mean? Because
the most commonly cited external costs that are not included here are health issues. So and pollution in an urban environment, if coal is being burned, for example, and climate change.
Right.
So one of the things about gas compared to coal is that per carbon molecule, the gas has about twice as much energy as coal. So consequently, if you're going to, and also a gas-fired electric generating facility usually will be more efficient than a coal-fired facility. So consequently, if we're just talking about consumption of this fuel at the location where we're producing electricity, then there's going to be a lot less impact in terms of global climate change if we're burning gas compared to coal. And there's going to be much less impact on human health because we don't have all the stuff that's in coal. It's not in the gas in the first place.
Right. Not to mention the extraction techniques of the mountain topping, right?
Yeah.
Right.
There's a lot of issues no matter how we get our energy.
Right. So are you ready for the anything else you want to cover on this one here?
No, let's just go to the next one here. So this actually describes some of the things that I was just mentioning, that natural gas is much lower in some of these conventional air pollutants. SOx means sulfur oxides. Okay, so if there's there's sulfur in coal. When you burn it, you're going to form sulfur dioxide, sulfur trioxide, and these things are going to go up into the atmosphere. Those are the ones that have to be scrubbed, Jeff.
Okay.
That's the main target of scrubbing.
Yep.
Mercury is more of a local issue. You can scrub to get the mercury out, but there's mercury in coal. There's not mercury in the natural gas. PM is particulate material. I mean, that's one of the things that is most closely associated with problems in human health if you have high particulate matter counts.
Right.
And you just don't get that with natural gas compared to coal. So the boxes on the left, we have our bus system here in State College area in the center region. They all run on compressed natural gas. And a lot of times they say instead of compressed natural gas, it's clean natural gas. So that's a selling card for them, that they're not polluting the atmosphere.
So it could come from fracking.
Yeah.
It could. No way to know, right?
No, but
it burns clean. It burns
clean. In this
clean.
case, we're talking about the impacts on the local environment.
Right.
When we burn it.
So the point of use, it's cleaner. Clean natural gas.
The point of use is definitely cleaner.
Yeah.
Yeah, so I have those issues identified down there too. That natural gas does not contain the impurities that you'd find in coal and petroleum products. Coal more than petroleum products, and natural gas would produce, if we just think about burning it and the energy that we get out of it, it produces 50% as much CO2. excuse me, as coal does, and it's probably a little bit better than that because the higher efficiency of gas-fired electric utilities.
That's fascinating.
So why don't we go on to but this other thing I have on here is that's not the whole story, because there's methane losses all the way through this process.
Oh.
And there's a lot of discussion. There's a lot of controversy about how much methane is lost between the time that they're doing the drilling and develop that well and the time that you're actually burning it in your home or it's being used to produce electricity. And so if methane escapes into the atmosphere, that's not so much. I mean, we've all seen these films of fire coming out of the faucets at Dimmock in Pennsylvania, right?
Yep.
Well, so that's a big problem. If you have methane that's getting into the groundwater supply, but methane itself, aside from being explosive, is not really a toxin. But it is a very potent greenhouse gas.
Right.
More potent, as a matter of fact, than carbon dioxide. So if indeed we are losing a lot of methane between the time we're taking it out of the ground and the time that it's being combusted, well, maybe we're creating some other problems there. And that's one of those places, Jeff, where there's a huge amount of controversy right now.
And I do like this particular flow chart here on slide 7. Is it safe to say this is, for the most part, the supply chain mapped out?
Yeah, that's pretty much the supply chain.
Okay.
That comes from a paper, so I have the citation down there for that paper, Environmental Research Letters.
Okay. And this is where I'm a process guy, and I really like to see, the machinery. In other words, when I hear fracking, I think, okay, what's the machinery, top to bottom, and I'm fascinated by the lack of transparency in the general literature and what's available to the public, because you can't see that machinery. You can't really identify, okay, at this point, there's some methane issues here, and then how much of an issue is there? You've heard of Six Sigma before, right? Mm-hmm. So I like Six Sigma because define, measure, analyze, improve, and control, DMAIC. And these very important environmental issues, like, folks haven't really got their head wrapped around the define part. Experts have. Global warming, you pick it. But from a scientific analysis perspective, really look at the machinery, look at the system. I really like that slide, at least the beginnings of it, and the idea that you could, continue to build upon that to develop this broader data set. And
identify where the contaminants are coming or where the costs are.
Right. Where the costs are and where the benefit is. And I'm sure along the supply line there's jobs, there's, good, clean, burning fuel. But you look at that whole picture, now you can affect policy. Now you can have a better discussion about true costs to the local economy, the local environment, to people. Anyway, not to jump ahead here too much, but...
That sounds like that's what you do, Jeff.
What's that? Jump ahead?
No. You just kind of work.
No, I don't. That's the thing. I deal with technology, I guess. And technology is more slippery because you can't really get a hold of a computer program. And, so with my civil engineering background... I bring that to at least what I do for the day job, which is, enterprises and technology and how all that stuff works. So, but yeah, I mean, I see something like this and I think, okay, good. We finally have the beginnings of some semblance of how this all works. Now the scientist in me, the engineer in me, the guy that's just endlessly curious wants to put numbers on that thing. Like, I'd like to see what that...
You go to there's 2 articles that are cited there. So if you go there, you might enjoy that.
Absolutely. Okay, so are you ready for the
let's do the next. So So this is just showing what's going on in terms of our energy use in the U.S. So that plot on the right is the primary energy production, and I highlighted the with red the natural gas. So you can see this going up over the last decade considerably.
A big
And
spike there in the 1960s and 70s.
yeah, and then it came back down. I couldn't tell you exactly why, but I presume that's because there was they developed those natural gas fields, and then they were starting to run out probably.
Wow.
But now we have a new source, this unconventional.
Unconventional, right? So that's a totally different extraction method.
Yeah.
It was. Is it safe to say it was cleaner to extract? The old method, the stuff that really peaked
Previously
there?
with a conventional?
Yeah, yeah.
Well, I mean, there was still production water that was coming up. I mean, I've done a lot of. I've had my fun projects, Jeff. Have been walking around the countryside of Pennsylvania, looking at acid bind drainage and checking out streams. And in the course of doing that, I've seen a lot of these oil and gas wells out there, and every one of them, if they're run properly, they have a tank that's accumulating the production water from the conventional production of gas or oil. And so they have to come out there and they have to take that away every so often, and those are usually very salty. So I wouldn't say that it's necessarily clean. I've been walking in the woods a couple of times too and seen uncapped conventional wells. These were wells that were supposed to have been plugged effectively, but they weren't. So it was sort of like the Beverly Hillbillies, the bubbling crude, except there was bubbling gas coming up with mud.
Flammable gas right there coming out of the
Oh
ground.
my God, yeah. So when I've seen that, I've called that into the Department of Environmental Protection. They've gone out and taken care of it, but I'm sure. There is a big problem with that, with the old conventional wells. If they don't have proper records, if it was not properly regulated, and if the people operating them were maybe a little bit unethical, or maybe they, it just broke over the years. But at any rate, there's a lot of methane that's coming up from those old conventional wells that are no longer in use. They're no longer producing. At least we're not capturing it, but they're leaking gas still.
I grew up in the country, northwest Pennsylvania, and I'm really glad that I didn't have any of that around me, because I guarantee, just the way we were as kids, I'd be like, oh, what's this coming out of the ground? It smells like we could light it.
Yeah, light a match.
Hey, this would be fun. Let's try this out. Wow. So I escaped likely some bad stuff.
Yeah,
just by not growing up in that particular part.
You escaped, Jeff.
What's that?
You've probably escaped several other things.
Oh,
too.
That's a whole other show. Right.
Yeah.
All right, we'll keep going here.
So the one on the left just shows that it's just a map of the United States showing some of the locations where they are retiring coal-fired electric generating power plants. And we've all heard about this, right? There's news all the time about this, because the CO2 is being regulated, because the particulate material is being regulated, because the mercury is being regulated. That it's in some cases then it gets to be too expensive to operate those old facilities. And so the plot on the right is the primary energy production, but if we looked at the energy that is being used, the type of fossil fuel that's being used for production of electricity, there would be an even greater increase in terms of natural gas compared to coal.
Wow.
Coal is still pretty much on the top, but you see natural gas is coming right up there. And the very bottom of that one on the right, you see that yellow one, that's solar. And we got biomass. So
fascinating. Look how low.
Other things coming up there. Nuclear is staying pretty level right now. That's the blue one, nuclear electric power.
Look how low. Unbelievable.
Yeah, but accelerate in terms of percent increase.
Oh, it's tremendous. Yeah, tremendous.
Yeah, it's much greater. So let's go to the next one then.
Okay, we're on slide 9 now.
Slide 9. Okay, so this is just some recent data. This comes from the Energy Information Agency. So this is Department of Energy Information Agency. They have a huge amount of data on their site and studies. And I just kind of like this slide because it shows by states where most of the new power is coming from. This is the U.S. power plant capacity additions 2013 by state. So the top one, the biggest capacity expansion is in California. That brown is natural gas. The yellow is solar.
Wow.
The green is wind. The next one is Texas. So in Texas, there's some new facilities that are coal, but there are more coal-fired utilities that are being shut down than the new ones that are being produced there in Texas. So you see Texas and Indiana both have a significant amount of new generation from coal, but there's other places where it's being shut down. But all that brown on there, and see in Florida, biggest, North Carolina, biggest, Arizona's it's solar, which is not bad. If you live in Arizona, you'd expect that to be the case, right?
Right, right.
So I think this is kind of cool because a lot of places where you see natural gas being used, you also see increases in solar and wind.
California is absolutely stunning. Look at that
Mm-hmm.
with the solar. Now, so all the stuff shown in brown, is that fracking
No,
related? Not necessarily, right?
it's any natural gas.
Any natural gas. Okay, okay.
Yeah. But but an increasing proportion of our natural gas is from fracking. We still have a lot of conventional too.
Unbelievable.
All
Okay,
right.
we'll go to the next one.
Yeah.
We're on 10 now.
All right. So this is the totally up in the upper left. You see total technically recoverable resources of dry natural gas. So the dry just means it's like they don't they're telling you the total mass, not counting any water that's in there. And so 54% of that is in tight formation, tight gas, shale gas, and coal bed methane. So those are tight gas and shale gas are same kind of category. These are in formations, as I described earlier, that are not permeable. There's very low porosity, and so you have to frack them in order to open up those pores and get the gas out. And then Alaska is still conventional. They're talking about doing some of that stuff up in Alaska, a lot of other things, but it's difficult working up there.
Right,
And then
right.
some the offshore and the 40 states. But 54% of the recoverable right now, that doesn't mean the amount that's produced, and I'm not sure what that number is. We could probably find it. 54% of the recoverable resource of natural gas right now is from tight formations.
And of course, it's increasing as they continue to find new sources. Wow.
And that proportion is increasing, exactly.
And look at that map, and it's amazing to see that whole northeast segment, Pennsylvania, a good chunk of Ohio, all the way down through. That's amazing how much that contiguous formation is all the way down through. And
Yeah.
and I imagine similar techniques, equal techniques in all these areas that are showing green here on the map.
Yeah, but there's differences in the quality of the gas, different areas.
Same concerns with the wells and the potential, like the types of chemicals used and that kind of thing.
Yeah, there's more similarity, I think, in terms of the chemicals that they're using, but in terms of the ability to extract that gas from the ground and how much is down there. That entire area that's shown there in the Marcellus, each square mile is not equivalent. Some places are better than others.
I see.
Pennsylvania seems to be pretty strong. So in Ohio, they're starting to develop the Utica, which is below the Marcellus.
Oh wow! Oh wow!
But I mean, it depends how deep it is, where you are, but it's below the Marcellus. And like in the Marcellus itself, if you go over to southwest Pennsylvania, then there's more ethane, propane, butane in there, and so there are industries that are popping up there that are accessing those fuels because they're actually more valuable. You can put them into a container. You can't. It takes a lot of pressure and cryogenic conditions to liquefy natural gas, but you can put propane into a tank and use it on your barbecue.
Right. Fascinating. Okay, we'll go to the next one.
Yeah, let's go to the next one.
Okay.
So this is just showing the net natural gas trade, and these are projections going out to 2040. So you see the line drawn across there is 2013, I guess, when this figure was probably produced. Well, this is actually a 2015 Energy Outlook, but I don't know when the last data they had. And so our history shown to the left of that vertical bar shows that we have been importing natural gas, mostly from Mexico and Canada. And the projections are that by approximately 2017 or so, we're going to be producing more natural gas in the United States than we're consuming, and so we can export if the laws allow us to do this. So this relates to what I told you before about these ports for liquefied natural gas. Previously, we thought we were going to use them to import gas from Saudi Arabia, etc. Now, we think we're going to be using those ports to export gas to Europe, Japan, China.
Wow. Well, and the recent situation with oil prices, how does that affect some of the math. I've heard like some of the wells were
both
stopped.
the price of oil and natural gas have decreased considerably. Oil is, both of them are coming back up a little bit. So oil was over $110 a barrel, and it fell to just below $45 a barrel. That's quite a drop.
Right, well over.
And right now, I haven't looked the last couple of days, but it's in mid 60s, somewhere like that. It's in the 60s dollars per barrel. So it's coming back up. That has a big impact on the feasibility of extracting this unconventional oil and the unconventional gas. So because the gas prices, they've not taken as much of a tumble, but they've taken a pretty big tumble too.
Absolutely. Okay, so we'll go to the next one.
Yeah. And this one just shows that that plot on the upper right. The figures of Pennsylvania show the permits per year, going through those years for conventional and for unconventional. And so I took those data that were generated in those figures and plotted in the upper right. The blue line shows the Marcellus, that is the unconventional gas well permits in Pennsylvania, and the dashed orange line shows the conventional wells, the non-Marcellus gas wells. So you see that with the rise of Marcellus, there's a decrease, also a simultaneous decrease in the number of new wells that are being drilled that are conventional wells. And each one of those, generally, each one of those Marcellus gas wells is going to yield a lot more than each one of the non-Marcellus gas wells too.
Right. Look at that.
The fracking, the frack gas, the unconventional gas is taking over in Pennsylvania.
Substantially, my goodness.
Yeah.
Now, help me understand that the map of Pennsylvania in 2008. Those were new permits.
Yeah, those were new permits.
And then 2009, those are uniquely new for 2009.
For 2009, for
Okay.
2010. So this also shows, those maps show you where most of those permits are going. That arc going from southwestern Pennsylvania into northeastern Pennsylvania.
Yep.
Those are locations where the Marcellus is most feasibly extracted.
Very good. All right, so the next one?
Next one, okay. So we got all those good things, but there's some issues here too. So we've all seen this probably if we've been up in some of the rural communities in West Virginia and Pennsylvania, that you've got these small roads and you got a lot of trucks going down those roads. So there's degradation of communities and roads and certainly of ecosystems just due to all that traffic and development that's occurring there. There's people who are really concerned about water use. To me, in Pennsylvania, since we're a relatively wet state, this is not nearly as much of a potential problem as wastewater that is being generated.
Right.
Just like with any industry, there's the possibility for contamination of surface and groundwaters. I mean, if you got a truck of junk, of hazardous waste or something that's being transported on the interstate, gets in an accident, you have a possibility for some problems there and contamination of surface and groundwaters. We certainly have those possibilities for fracking because we need a bunch of chemicals on site that are going to be used for the fracking process. We got this flowback water, and there's a possibility, since it's down so deep, that there's a possibility that there could be leakage from the pipe one direction or the other, and contamination of those aquifers through which it's passing. There are much better laws about this now, Jeff, than there were when the fracking started in Pennsylvania.
Yeah, I was going to say that the part about the air is fascinating. I've read a couple stories about fracking operations going on, and then folks downwind from those operations having contaminated air come their way.
Yeah, some of the places, especially out west, they've tried to get rid of the production water that's coming back by evaporating. So they might blow it into the air. Anything, of course, that is more volatile than the water is going to evaporate more than the water. And so there's lots of stories about chickens downwind and people, dying, people downwind getting sick.
Oh, people,
it's
actual
a
deaths?
Big issue here too. For example, should physicians in these areas have access to information about what chemicals are being used? How are they going to diagnose what's wrong with a patient if that patient has symptoms that might indicate that they breathe some contaminant?
So,
unless they know what that contaminant is.
There's an important metric, like how many folks are harmed by the air pollution from these operations. And then you said that people have died. How many
chickens have died?
People haven't died then.
No, I don't know of any people who have died from
But still,
this.
if you got dead chickens, I wouldn't want to be hanging out. You know what I mean?
Me neither.
Man.
People got sick. and it's allegedly due to, and I would I don't see any reason why there wouldn't have been some of these. One of the things, Jeff, about this is
I've never
it's
heard
not
of that.
like you have one company, that's responsible for stuff and is out there doing all the drilling. No, I mean you've got a whole lot of companies who have the rights, and then they've got subcontractors, and then they're pulling in pipeline people and drillers and folks who are hauling water back and forth. There's tens of thousands probably of companies and individuals who are working there, and you can't trust. It's like anything else. You just can't trust everybody.
Right, right. Well, and that's the other part too. And this is where the data set and the process flow charts and all, I mean, the whole infrastructure mapping needs to be laid out, because like the guy that said, let's evaporate this, right? The supply chain may be pretty well intact. And there's a guy that said, cheaper to evaporate it. You've changed the model now. Now you've changed the data.
Yeah.
Now you have a different data set. That's the part that I want to get at some point. I know that, I mean, it's a long conversation. It's an evolving conversation, but it's a necessary one, because when you hear those ads, you don't hear about dead chickens. Get me out of that neighborhood. My goodness. Okay, so you ready for the next slide?
Yeah, so just the last two things
I'm sorry.
Talk about later.
Oh, yeah, goodness, the earthquakes and the...
Earthquakes have been in the news, and greenhouse gas, but we'll get onto that later on.
Yep, that sounds good.
All right.
All right, we're on 14 now.
So, like here in Pennsylvania, too, there have been issues about having roads as well as drilling going on in some of the pristine areas. And as we mentioned before, a lot of people have heard about the problems in Dimmock, Pennsylvania, the Gaslands video.
Oh yeah,
about that, and I think that the best evaluations of that have indicated that it might not have been gas that came directly from the Marcellus, but it might have been gas that was allowed to penetrate into the aquifers because of perforation of these conventional gas fields. So why were they allowed to drill there in the first place?
Oh, is it?
There should be some places probably that should be out of bounds.
How do you pronounce that? Dimmock?
Yeah, that's what I understand. That's what a guy from the Sierra Club who was in one of my classes, that's the way he pronounced it. And he had worked over there, so I'm going with that pronunciation.
That sounds good. Is it known as the Gaslands?
That's the name of the movie, the video.
Oh, okay.
Yeah, this is the one with the people with gas masks, and they're lighting the flames on their faucets.
That's right. Okay.
Not funny if you live there, that's for sure.
So that's where the Gaslands movie was from.
Yeah.
I thought it was known as the Gaslands, and then decided let's shake the earth up a bit more.
That I know of, no.
Oh, goodness. All right, so ready for the next one?
Yeah. And so then another issue is, this shows Colorado, but similar issues in Pennsylvania. Our municipalities, our local governments, allowed to create their own laws about whether or not there's going to be drilling and pipelines and all this kind of stuff going across property. And in both of these cases, the state has denied the rights of the local communities to take control of those things. So not that I know a lot about it, Jeff, but I mean these are also continuing socioeconomic issues.
Yeah, and constitutional issues, I think, as well, because
exactly.
state rights versus local rights versus federal. I mean, I think that not to make this a political conversation, but I'm a big fan of local government. Like nothing better than a good, strong local government where people are informed and they're active in their communities. And I've heard a number of these different stories where, people have been in really terrible situations with a lot of the fracking that's going on, and they've got studies and they've got information, and they just want to hold off a bit so they can get more information. And there are powers at the state level that say, sorry. It's unbelievable.
Well, there's a lot of money involved in these things.
Right.
And when there's a lot of money involved in things, then people don't want to delay when they're ready to move. So
right.
Personal opinion.
Right. Full disclaimer. But again, the fascination I have with the science behind it, because at the end of the day, they're numbers, they're metrics, they're things that if they're transparent, the state level government should be able to make more informed decisions, I would think.
Mm-hmm.
So anyway.
All right. So that's just an issue, So I mentioned before that I thought that water use in Pennsylvania is not as big an issue as it might be in other locations. And so here's this is a report this completion report for a well was sent into the Department of Environmental Protection in Pennsylvania. And the things that I have indicated here, we talked about this before, this particular series of wells covered 608 acres. So that's closing in on a square mile. this particular well. And in order to develop, that's just one of the wells that would have been on this, drilled from this drilling
Just
pad.
one of the wells.
Yeah.
Wow.
And so where did they get the water in order to do the fracking on this? Well, about 1.3 million gallons came from a water utility, Pennsylvania American Water. I'm on a wastewater utility, and we're allowed to sell our wastewater reuse water to the fracking companies. We're a little bit further away, being we're not really in the Marcellus drilling territory, probably less than 50 miles away, but it would cost them a lot of money to transport that. But that 1.3 million gallons came from a water utility, potable water utility. But the interesting thing if you look down below, there was almost 2.6 million gallons, so about 2/3 of the water that was used for fracking was recycled water. That means that it was water that came back up from a previously fracked well, and they treated it sufficiently so they could blend it in and reuse that water. And that's where most of the production water in Pennsylvania is going right now for new fracking.
So
pretty interesting.
That 2.5 million, that came from previous wells that they reclaimed, stored, and then transported to a new well location? Yep. Is that right?
Exactly.
Okay.
Yeah, so that's a lot cheaper though than if that seems to be good for everybody. Yeah. And we can talk more about that later on. That seems to be good for everybody because it's going to be cheaper than sending their wastewater off to Texas or Oklahoma for deep well injection. Another big issue.
Right.
And also the trucking costs are huge. So if they're getting that from a well that's close by, then that helps them as well.
And we need to also understand more about how they clean it so they can reuse it.
Yeah.
And then where the solids go and yeah, it's.
There are a lot of issues. How do they do it? Well, in most cases, they're removing the solids. They're making sure there's no iron left because they don't want any precipitation down the well.
Right.
They initially thought they were going to have to be removing calcium and barium and strontium and radon and stuff, and so they may in some cases be doing some of that, but they're not having it. In most cases, they're not having to do too much of that.
That's good.
So the treatment is relatively simple.
Very good. So next one. I'm on 17
Next
now.
one, this is still about water use, and I think we're going to have to take a break here fairly soon. But why don't we finish with the water use, Jeff?
Sure, that sounds good.
And then come back later on.
Okay, that sounds great.
But the total amount of water that is being extracted in Pennsylvania for the Marcellus Shale is pretty small. Now, it's increased from this bar diagram. But in this bar diagram, this shows Pennsylvania's surface and groundwater withdrawals by industry, and I believe that was in 2009, perhaps. In thermoelectric power, they have to cool. Here's the deal: when you make electricity, most of the energy from burning that coal or gas or oil, in most cases, most of that energy is just heat that has to be dissipated before you can. You just can't let it go. You have to cool down the water that's used for the boilers.
Okay.
And so consequently, they get rid of that by evaporating some of the water. That cools the rest of the water. And so thermoelectric plants lose and use a whole bunch of water, whereas Marcellus Shale development over on the left-hand side was much less than thermoelectric, public water supply, industrial, and so on. But the fraction, the relative amount of water that's being extracted for Marcellus Shale fracking is increasing. So if you look at, it's a little bit hard to see the numbers on this plot, but if you look at 2011 compared to 2009 in that red-rimmed box over there, and if you look down at the very bottom, the natural gas extraction, in reported groundwater withdrawals, it went from about 0 to 0.9, and in reported surface water withdrawals, it went from 0.8 to 8.3. So it's becoming more significant,
right?
But it's still way below the electric generation, which is surface water 2,750.
So
way below.
With hydroelectric, that's hydroelectric generation, right?
No, that's like if you have the classic example is nuclear energy. Right?
Yeah.
Nuclear energy is only generally about 30% efficient. So, and all of these facilities operate by by boiling water that turns a turbine. In a cogen plant, then they'll also use that expanded gas to turn additional turbines. All right, but sooner or later they have to cool down that water that was turned to steam, and they have to return some of that water, and so by the way that they cool it is by passing it through cooling towers. So the classic in a nuclear facility are those what would you call that?
It looks. I just always think of 3 Mile Island.
Exactly.
The 3 Mile Island towers, right? But those,
yeah.
those could
so
be.
What you see coming out of the top of those is evaporated water, clouds of evaporated water. That's what that is. Okay. That's the water that is used for cooling purposes at conventional, nuclear, coal, gas, thermoelectric power plants.
Gotcha. Okay. And just so I understand too, so in that context, and again, I was a bit confused when it said electric generation because I thought that was hydroelectric, but electric generation equates to more or less the thermoelectric power plot on the right?
Yeah, it's probably everything but hydroelectric, solar, wind, because anytime you burn something or generate heat and then turn a turbine with steam, that's thermoelectric.
Gotcha. Okay. And the interesting thing too, for the amount of water being used on that particular chart there, it's being heated, but it's clean, right?
It's clean, but it's being lost. It's no longer surface water. It's going up into the air.
Oh, okay, that's right. Oh, wow. Wow. See, I thought there was an issue. Obviously, some of it's discharged back into streams, and there could be issues with thermal contamination of the streams, right?
Right.
Only so much they can put back, but a good portion of that's boiled off.
That issue too.
Unbelievable.
Mm-hmm. Yeah, that's a lot. So you see, if you go from right to left, thermoelectric power, public water supply, industrial extractions, farming, domestic water supply, mining, livestock, irrigation, and this is early on where Marcellus Shale was way over there. If you looked at this now, then we would have 8 million gallons a day, and so where would that be? It'd still be pretty low on this whole plot. Marcellus, the natural gas extraction.
It's not quite yet.
So if you're out west, or if you're in Texas, in some places where there's not enough water, then provision of water for the fracking processes can be an extremely crucial part of the whole thing. And it's an important thing to consider in Pennsylvania, but I don't think it's as important as the wastewater that's generated.
Absolutely. So do you want to stop here then? We'll pick it up.
Yeah, why don't we do that? And then pick it up another time.
That sounds good. So, Brian, thanks again. We'll cut it off here, and then we'll come back with part 2.
All right. Sounds great, Jeff.
Thanks, Brian. I really appreciate it.
Great talking to you.
Absolutely.